Welcome back to Daily AI Brief, your go-to podcast for the latest in AI tech. Today, we're diving into the world of AI substrates, exploring the powerful tool of Seedance for creative media, and dissecting advancements in sentiment analysis. So buckle up as we unwrap these exciting developments. When managing AI agents, especially in complex or compliance-heavy environments, having robust tools is crucial. Enter Shepherd, a game-changing open-source Python substrate for meta agents, developed by researchers from Northeastern University and Stanford University. Announced in May 2026, Shepherd is designed to improve meta agent performance by allowing operations like forking, replaying, and reverting agent runs, employing a structured, Git-like execution trace. So, what's the magic under the hood? Shepherd integrates elements of functional programming to formalize agent operations. Here's how it breaks down. Execution traces. Shepherd records every interaction as a typed event, creating a detailed execution trace. This allows agents to inspect and transform these traces as first-class objects, offering a level of granularity unseen in traditional systems that deal with static environmental states. Forking and reverting. By structuring these actions similarly to Git operations, it enables highly efficient changes, remarkably achieving process forking 5 times faster than Docker. This gives Shepherd an edge in scenarios requiring rapid rollbacks or simulations of alternative decision paths. Functional programming. This approach not only aids in historical state management, but also enhances runtime interventions and training processes, such as TreeRL. The use of functional programming principles helps ensure that operations are deterministic and easily replicable. For numbers, consider the substrate's efficiency. It demonstrates considerable improvements with over 95% prompt cache reuse during replays. This high reuse reduces computational overhead significantly, thereby boosting performance. While specific benchmarks for runtime interventions weren't detailed, the tool has already gained significant attention, accumulating over 1,400 stars on GitHub since its release. As with any tech, there are trade-offs. While Shepherd promises advancements, long-term scalability across diverse AI domains remains speculative. It may also introduce performance overheads in simpler environments and require understanding functional programming, which could be a barrier for some developers. Want to try Shepherd this week? Explore the official documentation, h/shepherdagents.ai/ and check out the GitHub repo, /osensite.analyze Shepherd Agents Shepherd for hands-on learning. Additionally, reviewing the research paper, huggingface.co/papers2605.10913 UDEM source OpenAI provides insight into its methodologies and applications. In conclusion, Shepherd significantly extends what meta agents can do, bringing granular control over AI processes. It not only enhances debugging and optimization, but also aids in regulatory compliance through its ability to audit and revert decisions. This development opens new avenues for AI research and could lead to the creation of new standards in meta agent programming. Imagine creating a microdrama in just 30 seconds. That's the innovation behind Seedance 2.5, recently announced by ByteDance at the Volcano Engine Force Conference in June 2026. This cutting-edge tool efficiently generates 30-second native video clips using up to 50 multimodal inputs, such as images, audio, and video, while cleverly bypassing traditional video stitching methods. Let's delve into the technical brilliance and potential hurdles of this transformative technology. The core innovation of Seedance 2.5 lies in its ability to process different types of content within a unified latent space. By integrating audio and video into a single processing pipeline, Seedance facilitates more natural and fluid video outputs. This seamless co-processing is a leap forward from earlier methods that required separate handling of audio and visual elements, which often led to inconsistencies and synchronization issues. Seedance 2.5 builds upon the diffusion transformer architecture, a hallmark of ByteDance's technology. This is a dual-branch architecture that allows for rapid adaptations and enhancements, ensuring that each content generation is both unique and contextually coherent. By leveraging AI, the process simplifies the traditionally labor-intensive tasks, dramatically reducing the time from content inception to completion. A significant feature of Seedance 2.5 is its API's easy integration, which has been available for public access since July 16, 2026. This API facilitates a low-latency process, enabling developers and creators to generate content with just a single API call. Such streamlined integration is designed for serious applications that cannot afford delays, further showcasing the tool's efficiency. Moreover, Seedance 2.5 offers video resolutions up to 720p, maintaining the benchmark set by its predecessor, Seedance 2.0, while extending the maximum clip length from 15 seconds to 30. The capability to produce a finished video in just seconds could redefine production timelines across media and advertising industries. Nevertheless, this technology isn't without its challenges. Unresolved copyright disputes with major entertainment studios, including Netflix and Disney, pose significant risks for market adoption. These concerns highlight the broader issue of intellectual property when using AI-generated content. Additionally, the tool's performance is contingent on the quality of the input material, which necessitates creators having high-quality assets to achieve optimal results. For those eager to explore Seedance 2.5's potential, accessing the public API http://seedancetool.com/seedance2-5 on the Byte Plus platform provides an excellent opportunity. Users can experiment with various reference materials to understand better how the tool adapts and processes inputs. ByteDance's official guides offer comprehensive instructions for utilizing these capabilities effectively. In summary, Seedance 2.5 is democratizing the world of video creation, streamlining the process to deliver high-quality, short-form media in an unprecedented timeframe. While it challenges traditional video production, it simultaneously prompts discussions around the ethical and legal landscapes of AI content creation. In the rapidly evolving field of AI-driven sentiment analysis, recent advancements integrating DistilBERT with low-rank adaptation, LoRA, have created a paradigm shift in how sentiment is analyzed across various platforms. By incorporating semi-supervised learning techniques and leveraging powerful tools like GPT-4 for generative annotation, this innovative approach addresses long-standing challenges such as dataset imbalance and computational inefficiency. The technical backbone of this approach centers around three main components. 1. DistilBERT. This model serves as the foundation for generating sentence embeddings. As a streamlined version of BERT, DistilBERT maintains much of BERT's effectiveness while optimizing for speed and resource efficiency. Its utility in processing text data quickly positions it as a potent tool in real-time sentiment analysis applications. 2. LoRA, low-rank adaptation. This adaptation technique introduces low-rank matrices within transformer architectures to facilitate efficient fine-tuning. By significantly reducing the number of trainable parameters, typically lowering the parameter count by up to 90% compared to traditional methods, LoRA allows for rapid adjustments to models without sacrificing accuracy. This makes real-world deployment on consumer-grade hardware both feasible and cost-effective. 3. Data augmentation techniques. Generative models, including GPT-4, are used to create synthetic data through methods such as back translation. This augmentation enriches datasets, effectively tackling the perennial issue of imbalanced datasets, a common hurdle in sentiment analysis. Enhanced data robustness leads to improved reliability of the sentiment analysis models. The impact of these technologies is quantifiable. Achieving 100% accuracy on benchmarks like the Twitter U.S. airline sentiment dataset is not just a testament to model efficacy, but also highlights the efficiency gains achieved within minimal training times and without extensive computational power. This marks an important development for businesses and researchers grappling with real-time sentiment insights. However, as with all pioneering approaches, there are considerations and limitations. The potential for overfitting, especially if models are not properly regularized during training, remains a risk. Additionally, the comprehensiveness of the LoRA and DistilBERT integration across varying domains, such as finance or social media, requires further scrutiny. Diversity in language usage and evolving trends pose ongoing challenges in optimizing these models universally. For professionals interested in leveraging these advancements, exploring Hugging Face's Model Hub is a pivotal step. Delving into available resources and GitHub repositories can provide practical insights into implementation and adaptation for specific use cases. In summary, the integration of DistilBERT and LoRA introduces a robust technology-driven toolset for sentiment analysis, poised to enhance interpretability and efficiency in AI applications across diverse industries. That's it for today's episode of Daily AI Brief. From substrates enhancing meta agents to advanced sentiment analysis and revolutionary media tools, the AI landscape continues to evolve. Stay curious and see how you can integrate these innovations into your projects. Until next time, happy coding.